Welcome everyone. In this session, we are going to discuss one of the most important CPU scheduling algorithm used in operating system, the non-primitive priority scheduling algorithm. Scheduling is a fundamental concept in an operating system because uh, because the CPU is the most critical and expensive resources. Every program or a process that wants to execute must first get the access of the CPU. But the CPU can handle only the one process at a time. Hence, it becomes the job of the CPU scheduler is to decide which process should be run next. There are multiple ways in operating system that can make this decision, and one of the most powerful method is priority scheduling. In today's lecture, we will deeply explore the non-primitive priority scheduling, including its definition, working example, calculations, advantages, and disadvantages of this comparison with other scheduling techniques. So let's start. In the first step, we will go through the overview of the CPU scheduling. Before diving into priority scheduling, let's recall the what CPU scheduling is. When the system has a multiple processes ready to running, the CPU scheduler selects one of them and allocates the CPU. The main goal of the scheduling is to maximize the utilization and minimize the waiting time of the process. The scheduling algorithm can broadly categorized into the two types. First one is a primitive scheduling, second one is a non-primitive scheduling. In a primitive scheduling, the running process can be interrupted and moved back to the ready queue so that another process can execute. The examples are the round robin round, the shortest remaining for time, first primitive priority scheduling. The next one is a non-primitive scheduling in which one of the process starts execution. It runs until its completion. No other process can interrupt it. For example, first come first serve, shortest job first, and these are the non-primitive priority scheduling. So the non-primitive priority scheduling belongs to the non-primitive category, means once the process gets the CPU time, it continues until it is finished. So the next part is what is a priority scheduling, why it is required and why it is important. In priority scheduling, every process is assigned to the priority number. The number determines how important the process is compared to others. The CPU is always allocated to the process with the highest priority. Priority can be represented in a two ways. That is, the higher the numerical values, that means it gives you the higher priority, or the lower the numeric values, that means it is higher priority, but it depends on the CPU conversion system convention. The idea here is the operating system should always run at the most important or urgent process first. For example, the system process like handling the keyboard input might have a higher priority than the background printing task. That's why the OS and priority scheduling are very much important. So, what is a non-primitive priority scheduling? Now, when the combine priority scheduling with the non-primitive nature, we get a non-primitive priority scheduling. The non-primitive priority scheduling is a CPU scheduling algorithm where each process is assigned a priority and the process with the highest priority is selected for the execution. Once the process starts the execution, it cannot be interrupted by another process. even if the higher priority process is arrived during this execution. So, if the low priority process is already running and the high priority process is arrived, the high priority process must wait until the CPU becomes free. This behavior makes the algorithm non-primitive. So working with the non-primitive priority scheduling, let's understand the algorithm, how it works by step-by-step process. So step one is each process in the ready queue has a priority number. So step two, the process scheduler checks all processes that have arrived and select the one which is the highest priority. Here in the step 3, once the process is selected, the that process is allocated. That is, once the uh, priority or the schedule or one of the priority number is decided, then GPU or then it allocates the CPU and executed until it is completed. It will not be interrupted by any of the external interrupt. Interrupt can be external or internal also. So after that, after completion, the CPU becomes the free and the scheduler again checks the ready queue for the next highest priority processes. This process will repeat until your job is completed, that is the task that is given to the CPU has completed. This process will repeat uh, again and again. Suppose now let's take the one example like you have three processes P1, P2 and P3. It contains the three different features like three different categories like arriving time, burst time and priority. In arriving time, suppose arriving time is 0 for P1, 1 for P2, 2 for P3 and burst time is 4, 3 and 1 respectively, and it given some priority like 2 for the P1, 1 for P2 and 3 for P3. So suppose at the time 0, what you think like which one will come first, P1, P2 or P3? Yeah, correct. So P1 is arrived. First P1 will execute because it is arrived at the time 0. So even if the priority of the P1 is 2, which are the higher as compared to the priority of the P2, until that P1 will execute, it will not check what is the priority of that task or process. So P1 will execute first. After 4 seconds or 4 units time, P1 finished their task and P2 and P3 are ready for the queue. Here, the in between the P2 and P3, P2 is a higher priority than compared to the P3 because it P1 contains a priority number 1 and P3 contains a priority number 3. So the P2 is a higher priority and the P3 is the lowest priority. So the CPU will execute the P2 process. After 7 unit, P2 completes and only the P3 process is left. So it will execute the P3 task until it is completion. So the final process will be P1, after that the P2, after that the P3. So the next one is the how they calculate the waiting time and turnaround time. So the here the process is P1, P2 and P3. The arrival time is 0, 1 and 2. Burst time is 4, 3 and 1. It is a time taken by the process to complete their task or execution of the time. Priority means it gives each process gives the one priority like 2, 1 and 3. It gives you start time and finish time, at what time it will start and at what time it is finished. Each process, how much time it is required, it is waiting for that waiting time available here for each one of the process. And there is turnaround time, like the time that is required. Yeah. So the if you want to calculate the average time of the waiting average time of the waiting time and turnaround time, that is second last and last column. Then what is the process of calculating the average of the all the processes? That is the sum of the all processes divided by total number of the sum. So you can calculate 0 plus 3 plus 5, that is uh, 7, 8 divided by 3, that is 2.67. And then the average turnaround time is 4 plus 6 plus 6, that is 16 divided by 3 is 5.33. So there are some important formulas to calculate the waiting time and turnaround time. Average waiting time and average turnaround time, you have to by heart or you have to remember these formulas, because it is formula is basic concept for calculating the this non-primitive scheduling. uh, Here the waiting time is difference between the start time and the arrival time. The turnaround time is the difference between the completion time and arrival time. The average of the waiting time is a summation of all the waiting time divided by total number of total number of the process. And the average turnaround time is a summation of all the turnaround time divided by the summation of the all the process. So, so let's start with the algorithms, step by step logic. First here the stepwise summary of the how the OS can handle the scheduling using the algorithm. Here the input of the list of the process along with their arrivals time, burst time, and priority. Sort this process according to their arrival time. So start from the first arrival process, and then at each scheduling point from the ready queue, select the process with the highest priority. It allocates the CPU to that processes. It allocates a dedicated CPU time for that processes. Let them execute it completely, which is non-primitive. Repeat this process until it is completed, and compute the waiting time and turnaround time or and average time of that process. The whole task or the whole number of the processes. Here the how to calculate the performance criteria of this primitive. Here it depends upon the number of factors like CPU utilization, throughput, waiting time, turnaround time, response time, and fairness. Here in the CPU utilization, how busy the CPU is, it gives the performance good or bad, or it takes too much time, or it is not good. And throughput, for the criteria throughput, the number of processes to be completed per unit time. It For the waiting time, it gives you the time spent in the waiting of the ready queue. Turnaround time, the time from submission to completion. Response time is the time from submission to first response. The fairness equals chance for all. It gives the equal chance for all the process. So the advantages and disadvantages of this non-primitive priority scheduling are the same. It is simple and easy to implement. It is conceptually straightforward and requires less time, little of the overhead, since no context switching occurs during the execution. It is effective for the real-time system. It is important task that can be assigned higher the priority, that ensures that they can run first. It is less overhead, since there is no primitive, there is no need for frequent context switching. It is efficient CPU. If it is efficient CPU utilization, the CPU is almost always the busy during the execution, and most of the important tasks are available. The disadvantages of non-primitive priority scheduling are the variation, that is undefined blocking. It is low priority processes. They may never get the CPU time if the priority if the high priority processes are keep arriving. Poor responsiveness once the process starts, even if the urgent task must be there. If the urgent task is there or urgent priority processes are there, they have to wait until it is finished. Priority inversion problem at the lower priority process may hold a resource needed by the higher priority process, that leading to inversion. Difficulty in assigning priority. It is often not a straightforward to determine which process deserve higher priority. Unfairness. It may lead to unfair the situation where the background or less important tasks are perpetually delayed. So, the coming to the conclusion of this non-primitive priority scheduling is one of the simplest and oldest method for CPU scheduling. It allows the system to decide which process is most important and schedule should be executed first. However, its non-primitive nature means it cannot respond immediately to the new high priority processes, which can be the limitations in a modern multitasking environment. Despite this, it remains a very good algorithm for a system where the context switching should be minimized, and where the tasks are predictable, such as an embedded system, batch processing, or the simple real time application. Always remember that a priority scheduling is about the importance, but fairness must be still to be maintained. That's why the combination of priority scheduling and aging that forms the basic of many modern scheduling algorithms. In today's fast forwarding world of multitasking, operating systems are the simplicity of the non-primitive priority scheduling may seem limited, but the foundation of the many advanced scheduler. Understanding it gives you the clarity about how the operating system decides who runs first, a question that lies at the heart of the computer performance. Thank you very much for the watching this video. If you like this video, please like, share, and subscribe to our channel. Thank you. We see you in the next video. Thank you.